Hi everybody, in this video I'm going to go through the review sheet for test number 6, which is our last test of the semester. So in question number 1, it says the pentagon in the diagram below is formed by 5 rays. And what we need to do is find the degree measure of angle x. The first thing that I need to do is use the relationship that the exterior angles here and the interior angles next to them are supplementary to each other. That means they add up to 180 degrees. So I can find that missing angle there by doing 180 minus 68, and that gives me 112 degrees. I can also do it over here with this 84-degree angle. 180 minus 84, let me type this into my calculator, is 96. Let me put that right over here. And finally, next to the 60-degree angle, I can find that angle that's missing by doing 180 minus 60, and I get 120 degrees. So what I have now is 4 interior angles of this pentagon. If I can find this last interior angle, then using the supplementary relationship, I can find x. So in order to find what all of the 5 angles of this pentagon should add up to, I'm going to use the formula that we have for sum of the interior angles of any polygon. That's the formula n minus 2 times 180, and n stands for the number of sides that the shape has. Since we have a pentagon here that has 5 sides, so I'm going to plug in 5 for n. So that's 5 minus 2, 180, which is the same thing as 3 times 180. If you go to your calculator and you type in 3 times 180, you will get 540 degrees. That means all 5 angles inside of this pentagon should add to 540 degrees. So what I'm going to do is I'm going to add up the 4 interior angles that we have, 140 plus 120 plus 96 plus 112, and I get 468. If I take 540, because that's what all the interior angles should add to, and I subtract 468, I'll be left over with that last interior angle that I'm looking for. And I get that that last interior angle should be 78 degrees. So using the relationship between the interior angle and the exterior angle right next to it, I can do 180 degrees minus 78, and I'm left over with, apologize over here, this is 72 when you subtract. 72, not 78. So on my calculator, if I do 180 minus 72, I'm left with 108, and that is my value of x that I'm looking for. In question number 2, it says one piece of the birdhouse that Natalie is building is shaped like a regular pentagon, as shown in the diagram. If side AE is extended to point F, what is the measure of exterior angle DEF? So we're looking for this angle right over here, one of the exterior angles of this pentagon. So we know it's a regular pentagon, so that means it has all equal sides and all equal angles. And we know that in any shape, all of the exterior angles always add up to 360 degrees, regardless of what shape it is. Since all of the angles are the same in this regular pentagon, all the interior angles, as well as all the exterior angles, will all have the same measurement since it is regular. So if I want to find out what just one exterior angle is of this pentagon, I can take 360 and divide by 5 because that's how many angles that there are in the pentagon. Pentagon has 5 sides and 5 angles. Going over to my calculator, if I do 360 divided by 5, I will get 72. And that should be the measure of each of the exterior angles of this pentagon. Moving on to number 3, it says the measure of an interior angle of a regular polygon is 120 degrees. So that's just one interior angle of a regular polygon. Once again, regular means that all the sides and all the angles are equal. So each of the interior angles of this polygon will have the same measurement. They will all be 120 degrees. And we are looking for how many sides the polygon has. Remember that we have a formula for finding what one interior angle of a regular polygon is. The formula is n minus 2 times 180, which is the sum of the interior angles of any polygon, divided by n. In a regular polygon, since all of the interior angles are equal, this should give us what each of the interior angles are. In this example, we know what each of the interior angles is. So we know what this formula will give us. We know each interior angle is 120. And what we are looking for is n, which is the number of sides that the polygon has. So all we have to do now is solve for n. So let me just multiply by n on both sides to cancel out the division by n. We have n minus 2 times 180 is equal to 120n. I'm going to distribute the 180 inside the parentheses. And let me subtract by 180n on both sides. And finally, we can divide by negative 60 on both sides. And we get, that n is equal to positive 6. So we see that this is a 6-sided shape, which is a hexagon. In number 4, we have a trapezoid, and it tells us that EF is the median of the trapezoid. We know that medians connect midpoints together, so another word for EF besides median is mid-segment. That's a word that's very familiar to us, mid-segment. They tell us in the question that AB, which is a base of this trapezoid, is 5x minus 9. DC, the other base of this trapezoid, is x plus 3. And EF, which is the midsegment, is 2x plus 2. And what we need to do is find the value of x first, and then find the length of EF. So first, we need to set up an equation to find x. So we know that the length of the midsegment of a trapezoid is equal to half the sum of the bases. So let's take the sum of the two bases, x plus 3 plus 5x minus 9. We need half the sum of the bases, so let's divide by 2. And that should be equal to the midsegment, which is 2x plus 2. Let me multiply by 2 on both sides to cancel out this division by 2. And I'm going to make sure to distribute the 2 to everything inside the parentheses. We have x plus 3 plus 5x minus 9 is equal to 4x plus 4. Let's combine some like terms together. 6x minus 6 is equal to 4x plus 4. Adding 6 to both sides and subtracting 4x from both sides, I have 2x is equal to 10. And dividing by 2 on both sides, that gives me x is equal to 5. To find the length of EF, all I need to do is take my x value and plug in to the expression 2x plus 2, which represents the length of the midsegment. 5 times 2 is 10, plus 2 is 12. So the length of EF is 12. Question number 5 says, using the information given below, which set of triangles cannot be proven similar? So if I take a look at number 1, I see a congruent pair of angles. Let's see if the corresponding sides that are given here are proportional by the same scale factor. So let's check out what the scale factor is for 12 and 4. Those are corresponding sides. And let's check out what the scale factor is for 9 and 3. So I see that 12 divided by 4 is 3, and 9 divided by 3 is also 3. So they do have the same scale factor, the corresponding sides, so they are proportional. So I see here that these two triangles definitely are similar by SAS. So that's not the answer choice we're looking for because they are similar by SAS. proportional corresponding sides with a congruent angle in between. Let's take a look at number 2. I see 2 pairs of congruent corresponding angles. They definitely are similar. That is by AA. Remember, if 2 pairs of corresponding angles are congruent, the third pair is automatically congruent as well, making all of the corresponding angles congruent. But 2 is enough for AA, and we have that here. Okay, let's take a look at number 3. So number 3 shows a congruent pair of angles, and it also shows 2 sides on each of the triangles. Now, the problem here is that even if I found the scale factors of the corresponding sides, these triangles wouldn't be similar because it wouldn't be AA because we only have 1 pair of congruent angles. It wouldn't be SSS because we don't know anything about the third pair of corresponding sides here. We don't have the measurements to compare the scale factors. And it wouldn't be SAS because the angle is not directly in between the 2 sides. So regardless of whether the sides are proportional, this wouldn't be SAS because the angle is not directly in between the 2 sides. So this is the answer choice we're looking for. None of our ways of proving triangles similar apply. Not AA, not SAS, not SSS. Nothing applies. These triangles are not similar to each other based on the information that we have. If we take a look at number 4 shows us 2 pairs of congruent sides with a congruent angle in between. So these triangles are actually congruent by SAS. But if we have 2 congruent triangles, they're also similar to each other by a scale factor of 1 because all of the sides are the same. So the scale factor would be 1. Multiplying by 1 gives you the same exact thing. So congruent triangles are also similar because if they're exactly the same size and shape, if they have exactly the same side lengths as each other, the sides are proportional by a scale factor of 1. So let's pick this out. Let me cross off this answer choice. Sorry about that. Not the one we're looking for. These triangles are similar to each other. They're also congruent. Okay, let's take a look at number 6. In the diagram below, AF and DB intersect at C, and AD and FBE are drawn so that the measure of angle D is 65 degrees, angle CB is 115, DC is 7.2, AC is 9.6, and FC is 21.6. And luckily, they labeled everything for us, which is really, really nice in the diagram already. So it says, what is the length of CB? So first things first, I need to know that these 2 triangles are similar to each other in order for me to use the fact that the corresponding sides are proportional to set up a proportion and find the length of the side that is missing that I'm looking for, CB. So I already see this 115-degree angle. I can find what the angle is next to it. 180 minus 115 gives me 65. So I see here we have a pair of congruent corresponding angles in the 2 triangles. And I also see vertical angles, which is a second pair of congruent corresponding angles. So already I see that the small triangle and the big triangle here are similar by AA. So now that we know the triangles are similar, we do know that the corresponding sides are in fact proportional to each other. We can set up and solve a proportion to find the missing side length CB. So let me create my proportion as the format 2 fractions separated by an equal sign. We want to find CB, so I want CB to be included in my proportion, and I'll just label it X because we're looking for it. So I'll put that in the denominator because I like to set up my proportions with side from small triangle over side from big triangle. Once again, that's the only way to set up proportions, but I just like to be consistent and do it the same way every time, and this is the way I like to do it. So let's check out what side of the small triangle corresponds to CB. Okay, so let me put 7.2 over here. That's the corresponding side from the small triangle. The only other side from the big triangle that we have is 21.6. And the side from the small triangle that corresponds to FC would be AC over here, which is 9.6. From here, all we need to do is cross multiply and solve for x. So let me multiply these two together, 7.2 and 21.6. Let me do that on my calculator. I got 155.52, and that's equal to 9.6 times x. Now let me divide both sides by 9.6. And I get that x is equal to 16.2. And that represents the length of CB, 16.2. We didn't know what CB was, so we labeled it as x. So that variable x that we just solved for represents the length of the side of the triangle that we're looking for. Okay, this is a word problem over here. So it says a flagpole casts a shadow that's 16.60 meters long. So here's my flagpole, and I'll label it the flagpole. And we know that shadows are found like on the ground. So let's say that this is the flagpole shadow. And we know, according to the question, it's 16.60 meters long. Let me close this up here so we have a triangle. We're also told that Tim, so let me make Tim. So this can be Tim, stands at a distance of 12.45 meters from the base of the flagpole, such that the end of Tim's shadow meets the end of the flagpole shadow. So I just moved Tim over a little bit. You can draw the triangles inside of each other, but I just prefer to draw them separately. So I just moved Tim over a bit. So here we have Tim, and at the bottom where Tim is standing, because shadows are on the ground, we have Tim's shadow. And it tells us here that Tim is 1.65 meters tall. And what we need to do is determine the height of the flagpole to the nearest tenth of a meter. So we're going to be using similar triangles here. And if you draw the triangles inside of each other, it's a lot clearer why these are similar triangles, because then they'll share another angle at the top and we'll have AA. But just so you guys can clearly see it, I just chose to draw my two triangles separately over here, even though the intention of the question is that one triangle would be inside of the other. So I just want to make that clear over here. So to use similar triangles, I'm going to set up a proportion in order to find what the height of the flagpole is. So I just want to make sure that I put corresponding parts together from the two triangles. So let me set up my proportion here. So let me take the flagpole, which is X, we're looking for it, from the purple triangle. And the corresponding side to this one on the green triangle would be Tim's height, which is 1.65 meters. Let me take 6.60, which is the length of the flagpole shadow from the purple triangle. And let me take on Tim's shadow over here. Okay, so the way that I set up this diagram here, it's going to be really hard for you guys to clearly see what goes in the bottom over here. So if you're following me so far, that's great, but I'm just going to reset and redraw my diagram the way that the question originally intended. I thought that drawing it like this would make it more clear, but we are going to start again and draw it the way that the question intended, so that way we can be able to complete the proportion in a very clear way. So let's reset. And if you were a little bit lost, that gives us a chance to see it again. So I'm going to draw big too. So I have a lot of room. So here's my flagpole. I can make it look like a flagpole. Here's my flag. And the shadow of the flagpole is on the floor. Shadows are on the floor. So I'm going to write that here, flagpole's shadow. And I know that the entire length of the flagpole shadow, according to the question, is 16.60 meters long. The flagpole casts a shadow that's 16.60 meters long. Okay, let me close this up just like we did before. And here we have a triangle, a right triangle to be exact. Now we're talking about Tim. And Tim is standing at a distance of 12.45 meters from the base of the flagpole. So Tim is standing like, let's say, so the whole length of the flagpole shadow is 16.60 meters. So here's the base of the flagpole. That means the bottom of the flagpole. So Tim is standing somewhere that is 12.45 meters from that bottom of the flagpole. So Tim could be standing right over here. Let's make this Tim. Here's a person. I'm going to call this Tim over here. And we are also told that the end of Tim's shadow meets the end of the flagpole shadow. So here in red, here's Tim's shadow, because shadows are on the floor, they're on the ground. You can see them on the ground when you look in front of you. So here's Tim, and here's Tim's shadow, and Tim is kind of looking at his shadow over here. Okay, wonderful. This is a lot easier to see now, drawing the diagram this way. So it says Tim is 1.65 meters tall. So I'm going to put that here. Tim is 1.65 meters tall. And what we are going to do is determine and state the height of the flagpole to the nearest tenth of a meter. So I don't know how tall the flagpole is. That's what we're looking for in this question. So I'm going to label that as X over here. And now we can set up our proportion, and it's going to be a lot more clear to us what goes in what spot. So let's start up our proportion the same way that we were talking about before. I'm going to take the side from the large purple triangle, X, and I'm going to put it over the corresponding side from the small red triangle over here that's formed by Tim and Tim's shadow. And that would be the side that's labeled 1.65. This is the height of the flagpole. This is the height of Tim. And once again, I'm able to set up a proportion involving the corresponding sides of the big purple triangle and the small red triangle because these triangles are similar. As you can see, they are both right triangles because this is a real world problem. So these are both right triangles over here. That's one pair of congruent angles. And as you can see, both of the triangles share this angle over here. So that would be congruent to itself by the reflexive property, making the two triangles similar by AA. So just keep that in mind. We do have similar triangles here. They're similar by AA, the big, large purple one and the small red one. And that's why we are able to set up a proportion. Okay, so now let's take the other side we have information about from the big purple triangle. That's 16.60. That's the flagpole shadow. And we're going to put that over Tim's shadow. So I need to figure out the length of Tim's shadow. I know that the whole flagpole shadow is 16.60 and that Tim was standing 12.45 meters from the bottom of the flagpole. If I do 16.60 minus 12.45, I'll find out how long Tim's shadow is. So let me do that on my calculator. 16.60 minus 12.45, and I got 4.15. So I'm going to put that here. I found that Tim's shadow is 4.15. And I'm going to put that here because that corresponds to this side of the large purple triangle. And from here, all I need to do is cross multiply and solve for x. So we have 4.15x, let me put that down here, is equal to, let me do 16.60 times 1.65 on my calculator, and I got 27.39. And now to divide both sides by 4.15, I got that x is equal to 6.6. So the height of the flagpole is about 6.6 meters. I know that we usually use like inches and feet. We don't use the metric system like meters, but it kind of makes sense because Tim is only 1.65 meters tall, and the flagpole is probably taller than Tim. It's probably a lot higher up than Tim, and it is. It's 6.6 meters tall, so that makes sense in this real world situation. Okay, question number 8. Triangle ABC, D is the midpoint of AB, and E is the midpoint of BC, so DE is the midsegment. AC is 3x minus 15, and DE is 6, and we need to find x. Remember that in a triangle, the midsegment is half the length of the base of the third side, which is the side that the midsegment is touching. So I can set up an equation that says if I take the midsegment and I double it, I will get the length of the base or the third side of the triangle. So here I have 12 is equal to 3x minus 15. Adding 15 to both sides, 27 is equal to 3x. And I get that x is equal to 9. Okay. In triangle ABC, oh, we just did this one. That was the same exact one that we just did. Yes, it was. So we're not going to do number 9 again because that was the same one we just did. That was a repeat. In the diagram below of triangle GHJ, K is a midpoint of GH, and L is a midpoint of HJ. So KL is the midsegment. If the measure of angle LKH is 79 minus x, so that's this angle right here, 79 minus x, and measure of angle JGK, so this angle right here, is 99 minus 3x, what is the measure of angle JGK? So we're looking for this angle here, which is represented as 99 minus 3x. In order to answer this question, we need to remember that the midsegment of a triangle is parallel to the base, to the third side of the triangle, to the side that it's not touching. So these two angles would be corresponding angles because they are in the same position where the parallel lines are crossed by the transversal, top right, top right. And we know that corresponding angles are congruent when parallel lines are cut by a transversal. So we can set up and solve an equation that says that. Adding, let me add 3x to both sides and subtract 79 from both sides. So if I add 3x to both sides, I have 2x over here. And if I subtract 79 from both sides, I have 20. Dividing both sides by 2, I have x is equal to 10. And now I can plug in to find the measure of the angle that I'm looking for, 99 minus 30. And that would be 69 degrees. Directed line segment PT has endpoints whose coordinates are -2, 1, and 4, 7. Determine the coordinates of point J that divides the segment in a ratio of 2:1. The use of the set of axes below is optional. So we're going to be dividing the line segment in a 2:1 ratio. So we're going to do it both ways, graphically and algebraically. You can do it either way, whichever way makes more sense to you. Let me pause for a second and just graph the line segment. Okay, I zoomed in as well because in order to do this graphically, it is important that you are super accurate with your graphing. Otherwise, you're not going to get the right answer if you're not super accurate with your graphing. So the first thing that I need to do here is I need to realize that if I'm dividing this in a ratio of 2 to 1, then there's going to be 3 parts in total that I'm dividing my line segment into. The point that I'm looking for, there's going to be 2 parts of the line segment to the left of it, and there's going to be 1 part of the line segment to the right of it. So that's 3 parts in total. So I'm just going to write that here for now. I'm going to count the boxes up and to the right so that I can see what the change in x is. That would be left to right. And what the change in y is, that would be vertically over here, from one endpoint to another endpoint over here. So counting 1, 2, 3, 4, 5, 6, that would be 6. And counting this way, 1, 2, 3, 4, 5, 6 as well. So the change in x and the change in y would both be 6. Now I know that I am dividing this into 5 parts. So I'm just going to take the change in x and the change in y and divide both by the number of parts, which is 3. And 6 divided by 3 is 2. So that tells me what my rise and my run are going to be to split up this line segment. Once again, 6 over the number of parts is 2. 6 over the number of parts is also 2. So that tells me this would be my rise because it's vertically over here. So my rise is 2. That means 2 up. Over my run is also 2. 2 to the right. And I can use this movement to split up or partition my line segment into the 3 parts. Find the point that splits it into the 2-to-1 ratio. So starting at the bottom endpoint, the starting endpoint, I'm going to go 1, 2 up and 1, 2 over. And I mentioned before how the accurate graphing is super, super important. Let me just make sure my original line segment was graphed super, super accurately. Otherwise, I'm not going to get the correct point here. So let's try that again. 1, 2, 1, 2. There we go. 1, 2, 1, 2, 1, 2, 1, 2. So notice we have now partitioned the line segment into 3 parts, which is what we wanted. 1, 2, and 3 parts. We need to find the point that has 2 parts of the line segment to the left of it and 1 part to the right of it. And that would be this point over here. There are 1, 2 parts of the line segment to the left of it and 1 part of the line segment to the right of it. So that would be the point that divides this line segment in a 2 to 3 ratio. So that would be the point 1, 2, 1, 2, 3, 4, 5. So that's the point 1, 5. So that was graphically using the graph. We can also do the same thing algebraically and see that we get the same answer. So we're going to do algebraically over here. I'm going to label it 2 because it's the second way to do it. Remember, we have a couple of steps. The first thing that we need to do is find the change in x and also find the change in y. And if you wanted to do this all algebraically, you can use the points that you're given here. The change in x would be x2 minus x1, which is 6. The change in y would be y2 minus y1, which is also 6. Then you can multiply your above answer by the fraction that you're using, and that's the same step 2 over here. So I'm just going to draw an arrow so I don't have to rewrite it. So remember we talked about how a 2-to-1 ratio means we're dividing the segment in 3 parts. So the fraction that we'd be using is 2 over 3 because there's 3 parts in total, so that's the denominator, and the 2 is written first. We want 2 parts to be to the left of the point, so that would be 2 over 3. We're splitting into a 2 to 3 ratio. a 2-to-1 ratio. So that, sorry, 2-to-1 ratio. So that would be 2/3. So if I take 6 and I multiply by 2/3, you can use a calculator for this. But I got 4. And over here, if I take 6 and I multiply by our fraction 2/3, we should get the same thing. We should get 4. And now our last step is we are going to add the result to the starting x value. And I'm going to put slash starting y value, because for the y coordinates, it's the same thing. We're going to take our starting y value and we're going to add the value in. So our starting point was the point P. That was the first point. That was where we're starting at. It's a directed line segment, so it does matter which one you're starting at. So the x coordinate's -2 and the y coordinate is 1. So since the x coordinate is -2 and the y coordinate is 1, I want to add the 4 to -2. And I want to also add the 4 to the 1. And I see here that I get 2 for the x coordinate. And I get 5 for the y coordinate. So that would be the 0.25. Oh no, did I miscount before? 1, 2. I said 2 out loud, I believe. And it's graphed as 1, 2, 1, 2, 3, 4, 5. But I wrote down 1 instead for some reason. So we got the same point, both graphically and algebraically. Whichever way you want to do it is perfectly fine. Just choose the way that you like and do it. It doesn't matter as long as you get the point. Find the area of the polygon below. Okay, so what I'm going to do is I'm just going to draw a box around the polygon. And I want to include as many of the vertex points as I possibly can. I'm not going to get this one in, but that's okay. So I see here that I have 2 right triangles. And I also have a third shape here. It looks like a rectangle. So I'm going to find the area of the entire box of the whole thing. So area of the whole. And that is 1, 2, 3, 4, 5, 6, 7. This whole thing is 7. 1, 2, 3, 4, 5, 6, 7, 8. This is 8. So length times width would be 56 units squared. Okay, now I'm going to find the area of triangle 1, which is 1/2 base times height, which is 1/2, 1, 2, 3, 1, 2, 3, 4, 1/2 12, which is 6. I also need to find the area of triangle 2. So that's going to be 1/2 base, which is 1, 2, 3, 4, times height, which is 1, 2, 3. So that's half of 12, which is once again 6. And then we have the area of the rectangle, which is shape number 3, and that will be length times width. So we have 1, 2, 3. From here to here is 3. 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5. Almost messed that one up over here. 5. So we have 3 times 5, which is 15. So we're going to take the area of the whole, which was 56, and we're going to subtract off the areas of the other shapes surrounding the one that we're interested in. And that should leave us over with the area of the shape that we actually want. So 15 plus 12 is 27. So 56 minus 27 is 29 units squared, and that would be the area of the shape that we're interested in. Okay, a few more to go. This is turning into a long video because of I'm taking a little bit longer than I thought with some of these questions. So let's take a look at number 10. So it says here the vertices of square RSTV and it gives us the coordinates, and we need to find the perimeter. So let me take a second and graph this so we can see it more. Okay, so unfortunately for us, these are all slanted lines. None of these are straight vertical or horizontal lines. So this is going to be a lot of distance formulas for us. So let me pause the video so I'm not on here for the next 2 hours, and I will compute my distance formulas, and then I will resume the video. So we know it's a square, so all the sides are equal. So actually you only have to find the length of one side. I don't know why I use the distance formula and found it at 3 sides, but for a square, you only need to find the length of one side because a square has 4 equal sides. So if I found that the first one has a length of radical 20, which simplifies to 2 radical 5, that means they all have length 2 radical 5. So to find the perimeter, we're going to be adding 2 radical 5 by itself 4 times, or multiplying by 4. So I have here 8 radical 5 is the perimeter. Okay, so the next one is asking us to find the area of the triangle formed by the 3 points of intersection of the lines here. So let me do this one with you guys, all the graphing and everything, even though it's going to make the video take a long time, doesn't really matter. So if we're graphing the line y equals 5, that's going to be a horizontal line. And it's going to include the 1, 2, 3, 4, 5, all the points that have a y coordinate of 5. Let me just graph that a bit better. 1, 2, 3, 4, 5. There we go. That's the line y equals 5. Okay, now the line x equals 4 is a vertical, x equals -4 is a vertical line, and that includes all of the points that have the x coordinate of -4. So -1, 2, 3, 4. There we go. That's the line x equals to -4. Now we need to graph the third line. We have the y-intercept is 5. 1, 2, 3, 4, 5. And the slope is 5 over 4. So that's up 5 over 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Then we can do the reverse to find the other points. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. And if I connect that with a line, that is the line y equals 5 over 4x plus 5. So now I really easily and clearly see the triangle formed by the 3 points of intersection of these lines. And it's pretty clear what the base is. This is a right triangle, so it's really clear what the base and the height are. So I see that the base is 1, 2, 3, 4. Oops, I grabbed that really badly, so we can't see. So I'm going to get rid of the yellow so we could see better, so we don't mess this up. I think it's better if I just like outline the intersection point. So the base is 1, 2, 3, 4. You don't want to confuse that for 5, and it's a right triangle. And the height is 1, 2, 3, 4, 5. So area is equal to 1/2 base times height. And half of 20 is 10 units squared. That question just looks scary, but it really wasn't all that bad. That took us about 2 minutes to do in total. We just had to remember that equations of lines that have y equals and nothing else, just like y equals 5, y equals 6, y equals a number, are horizontal lines. Lines that have the form x equals a number, like x equals -4, x equals 5, x equals 6, x equals whatever, those are vertical lines. And to graph any other line, you start at the y-intercept, and from there, you use the slope to graph. Rise over run tells you how much to move up and how much to move over. Oh, there's another question here. Given quadrilateral ABCD with the following vertices, determine what kind of quadrilateral this is and explain how we know. Okay, so let me take a second and graph this. I'm going to pause and then I'll resume when I have. So honestly, it kind of looks like a trapezoid after I graph it, but that's not enough to show that it's a trapezoid. So what I'm going to do is, since I think it might be a trapezoid, I know that trapezoids have only one pair of parallel sides. So what I'm going to do is I'm going to find the slope of all four sides. And if I find that only one pair of sides has the same slope and the other pair doesn't, then I know for sure that this is a trapezoid with only one pair of parallel sides. So I'm going to pause and calculate my four slopes, and then I'll resume. So based on the slopes that I found, this is a trapezoid because there are only one pair of parallel sides, the bases DC and AB. Part B is asking us to find the equation of the line parallel to AB that passes through the midpoint of BC. So BC is a leg of the trapezoid, and we know that if we connect the midpoints of the legs together, we get the mid segment of this trapezoid, and the mid segment of a trapezoid is parallel to the base, to both of the bases. So basically, this question is asking us to find the equation of the mid segment, but it's specifically as our point wants us to use the midpoint of BC. That's what it's telling us here. So let me first find the midpoint of BC because that's going to be the point that we're going to be using. So let me average the x coordinates of B and C, that's 9 and 4, comma, let me average the y coordinates 1 and 6. And that's 13 over 2, 7 over 2. Might be a little bit easier to get in this case because we're doing equation of a line to get the decimals. 13 over 2 is 6.5. And 7 over 2 is 3.5. But fractions are fine as well. You don't need to make it into a decimal. Sometimes I like fractions better. Sometimes I like decimals better. It really just depends on the question. So we have the point that we're using. That point is on the mid segment of the trapezoid because it's the midpoint of one of the legs. And now we just need the slope. It tells us that it should be parallel to AB. We know that the mid segment is parallel to the bases. And we already found that the slope of the bases is 1/3. So we have our slope is 1/3. So I'm going to use point slope form, which is y minus y1 equals to slope x minus x1. I'm going to plug in my y coordinate that I'm using is 3.5. The slope that I'm using is 1/3. And the x coordinate that I'm using is 6.5. You can leave it as is. The question does not say to solve for y. If it did, then we would have to distribute. That would be y minus 3.5 is equal to 1/3 x. Let me get my calculator. I'm just going to leave it as minus 6.5 over 3 because that is a large decimal. And then if we add 3.5 to both sides, if you use your calculator, you will get 4 over 3. So that would be y equals 1/3 x plus 4 over 3. But if the question doesn't ask you to solve for y, why do it? You can just leave it at this step after you plug in your point and your slope. And that's perfectly valid. The last question is asking to explain the difference between congruent triangles and similar triangles. Congruent triangles are exactly the same size and shape. So I'm going to write here congruent, exactly the same size and shape. Remember, if triangles are congruent, then they have congruent corresponding angles, and they also have congruent corresponding sides. Similar triangles have the same shape. Let me move this away. same shape, but different sizes. And if two triangles are similar, their corresponding angles are congruent, just like with congruent triangles, but their side lengths, their corresponding side lengths, are proportional. And we have three different methods of showing that triangles are similar, so I'm going to put them here. The first method of triangle similarity is AA, and that means that there are two pairs of congruent corresponding angles. The second way that we have of proving two triangles similar to each other is SSS, and that's three pairs of congruent corresponding sides. So, three pairs of proportional corresponding sides. So, for example, this could be 10, this could be 20, and this can be 30. And let's say we have 20, 60. Oops, sorry about that. And here we have two triangles that are similar because their corresponding sides are proportional by a scale factor of 2. 10 times 2 is 20, 30 times 2 is 60, and 20 times 2 is 40. And finally, we have our last method of proving triangles similar, which is SAS. So that is when you have two pairs of proportional sides with a congruent angle in between. So let's say this is 4 and this is 8, 12, and 24. These two triangles would be similar by SAS because we have two pairs of proportional corresponding sides. They both have a scale factor of 3, and there is a congruent corresponding angle in the middle.